the needful.
Sure.
I'm making you as a co-host,
Sure, sir.
and now I'm making you as a presenter also.
Sure.
A few minutes.
That's yes. No,
Uh,
no problem.
You can start.
So you can let me know, sir, once it is done.
Yes. Uh, Good morning, everyone. So let us welcome for today's day number 3. Day number 3, session 1 by Dr. Vinay Chamola. He will be taking the session number 6 on security and IoT. Let me introduce Dr. Chamola. Dr. Vinay Chamola is currently Assistant Professor in Department of Electrical and Electronics Engineering, Pilani campus. Dr. Vinay received his BE degree in Electrical and Electronics Engineering and Master's degree in Communication Engineering from Pilani campus in India in 2005, 2010 and 2013 respectively. He received his PhD degree in Electrical and Computers Engineering from the National University of Singapore in 2016. From June to August 2015, he was a visiting researcher at the Autonomous Network Research Group at the University of Southern California, USA. After his PhD, he worked as a postdoctoral researcher at the National University of Singapore in the area of Internet of Things. His research interests include IoT security, blockchain, 5G resource management, drones, VANET, and BCI. He is an associate editor of the IET Quantum Communication Journal and also a guest editor in the Computer Communications Journal elsewhere. He is a senior member of the IEEE. So let us welcome Dr. Vinay. Welcome, Dr. Vinay.
Thank you. So for sharing the slides, I just need to click the share and then I just need to choose the slides, right?
Dr. Vinay.
Yeah, sir. Can you hear me? Can you hear me?
I think what we can do, we can turn off the video. In that, we'll be saving some bandwidth.
Okay, okay, fine. Sure. Fine. So for sharing the slides, just need to do share and share content, right, sir? So am I audible? Can you kindly confirm, sir? Okay, fine, sure. So let
Yes,
me
sir, you
share.
are audible. You are perfectly audible.
Yes, sir. Fine, thank you. Okay, so can you see the slides? I hope everyone can see the slides, right?
No, sir.
I
It is
think
coming, sir. It will come. Yeah, it came.
fine, fine.
Yes, it's coming now.
Yes, sir. Now it is visible.
Okay, so
Audio is not coming, Dr. Vinay.
I think people are able to hear. Can someone kindly?
Yes. Everything is fine. Working,
Yeah,
sir.
Fine, fine,
Audible, sir. Audible.
it's audible.
Everything working.
fine.
Sir, you are audible, sir.
Okay, thank you. So basically today's presentation, I'll be, as this PP is mainly focused on agriculture, right? So today's session, I'll be mainly highlighting on security for agriculture IoT applications, right? So in the previous sessions, you must have actually got the basics of IoT and say something like cloud computing and so on, whichever are basically are the recent emerging trends and which are actually penetrating in areas like agriculture and so on. So now today's session is mainly about where does actually security come into picture, right? Like in generally, if I say you, okay, you go to the bank and you transact and so on, right? You, of course, you put more trust on that kind of thing, and you know that okay, the chances of fraud are much more less. But as soon as you say that okay, you are doing the net banking and so on online, right? It becomes a immediately question comes in mind. Is the app which I am using secure, right? Is the browser which I am using, is it secure, right? That's why people go for something like HTTPS and so on, right? Because as soon as you put anything over internet, right, its security becomes one important concern, right? Similarly, for the agriculture area also, although in India currently you don't have so many smart farming prototypes, but as envision that in the near future India may move towards that, it's important to understand that what kind of security challenges will come along with this particular kind of thing, right? So as Sir had introduced, right, I did my PhD from the NUS and I did postdoc also in IoT. And recently I have been very actively doing research in the area of IoT. So I have even at BITS Pilani, I established the IoT lab, right? And we have been working in these different areas. IoT security is one of the main of them. And then you have blockchain, 5G, UAVs, WAN. And we have been collaborating with different collaborators worldwide, like Rajkumar Bhuiya, so he's the IEEE fellow, Moshin Guzani, Nirvan Ansari, Richard Yu, and so on. So we have several collaborations, and in recent past, we have been able to successfully publish our works in reputed venues like IEEE Wireless Communication and different IEEE journals and conferences. So these are like some of the
Dr.
kind of
Vinay.
prototypes. These are some of the prototypes which we have actually developed in our
Hello.
lab. Yes, sir. Is anyone saying anything? I think someone interrupted. Fine. So we have unmanned aerial vehicles. So we are actually looking into that. It's exploring. It's basically application.
Mr. Iqbal, can you turn off your video?
So we
I
have been.
request everyone to turn off their videos.
So we have been exploring different research challenges in unmanned aerial vehicles. So one of the application area of unmanned aerial vehicles, if I specifically take something like agriculture, is that you can have drone-based monitoring of basically the crop pests, crop diseases, and so on. Right. So if you have very big kind of patch of land where you have different kind of crops put and all, at times what you have is you may have crop diseases. Now these crop diseases, the way they spread is, first of all, that actually starts from a very small patch of land, right? Like I don't know how many of you have flowering pots and so on in the house, but you'll see that at times, say if you have tulsi or you have any like flowering kind of plants in your house, you will see that initially it starts with little bit, say, spiders coming and all of a sudden, like gradually they immediately expand, and then it becomes very difficult to control. So similarly, when you have like big farmlands, you may have the problem starting at one small patch of land, and from that it is basically extending to the whole thing. So to detect that is a very important thing. So now manually, like say if you must be going from say your place to Delhi or anything, you'll see that on both sides of land, like hectares of land are there, which are basically like farmland kind of thing. Now going and tracking each and everything and all, like crops and all, at times becomes very difficult. So unmanned aerial vehicles, they can actually help in terms of they can actually go around, right? And then they can actually do some imaging, and then you can actually have trained models over them on a small say microprocessor, and it can basically click images and so on. It can do processing to tell where in which patch of land which kind of disease is actually happening, and then you can actually curb it at the right time. Similarly, at times it can monitor the soil moisture and so on using different kind of imaging techniques. So they can also be used, right? So similarly, we have been doing different kind of things like in molecular networks, in brain computer interface, water quality monitoring, all different kind of applications. Many of them they actually relate very much to the agriculture. So now specifically talking of agriculture, you know that the population of is increasing very much. Not only of India, but the world population also is increasing very much. And the projections are that the population will increase very, very quickly. And that will actually require more food production naturally. And then we have to actually rely on technologies. We need to rely on smart farming techniques, right? So as to be able to manage, right, so much yield of produce. As you must be seeing, many of the people, they are actually transmigrating from villages to cities and also on for job, right? And for those people who are in villages, it's quite difficult to manage, right, such big land. Like if I have to take my personal example, right, when I was child, I used to plow the fields when I was in my village in Uttarakhand. But now you see, when hardly I go to my village, but when I go, I see that people have left agriculture. There hardly anyone is doing agriculture. All the land is just lying like that. So that's the kind of scenarios which are actually coming up in the recent times, that people are migrating from villages to the cities, and there's no one to right take care of the land. And at times, even if someone is personally taking care, right, at times it's not in their caliber to take care of the entire field. So in such kind of scenarios, if you have smart farming techniques, you can increase the yield very much. Like in say many of the say other countries like Australia, US, these are quite big countries, and agriculture is one of the key like industries in them. So there they have hectares of land where they are using automation and so on for doing the agriculture to increase the yield. So now coming to the impact of smart farming techniques, right? So you can say in a particular country where we have Chile, right? They had kind of test bed setup where they use these smart farming techniques, and they could see that the remote sensors, right? They could decrease the volume of water required for irrigation by 70%, right? So as all of you know, the water is very, very like a scarce resource, and right at times what happens is the motor is just on and overwatering is there. Of course, one disadvantage is there, that the water gets wasted, but at the same time, it spoils the yield of the crop also, right? There are certain kind of crops which require a lot of water. Like if you say rice, right, it has to be filled with water. The whole field has to be filled with water for it to actually grow. But then there are certain kind of other crops, right, like say wheat and so on, which don't require so much water. If you put more water, right, not only you are wasting water, but you are actually damaging the crop also. So there have been test studies and so on where people have actually used these kind of smart sensors in the kind of farmland, where they are actually using it to measure the soil humidity, right? Soil humidity can be easily measured by having, you can have a soil humidity sensor, and then you connect it to say node MCU or Arduino and so on, and then further you can make a network, and you can have certain automation that once the water is like humidity is above a particular value, you stop giving the water and so on. In India, basically, you can use the smart farming technologies for various things, like you can predict crop diseases, right? So these like here in bits, we have been working on different kind of projects. So one project is basically that the farmer, right, because he doesn't know, and means he may not know exactly what kind of disease is this crop getting actually. So we are developing a kind of app. So on that app, just the farmer, just it's like easy for him. He just goes, clicks a snap of that, right? And then our tool basically does the processing of, so we have in the back end, right? We have all different kind of data sets of different kind of disease plants. So say if you take rice crop, so the farmer says, okay, I am actually growing rice in that rice, and then he clicks a photo. Then we check in our data set that, okay, which all diseases rice generally has, right? And we process that particular image to detect that what kind of basically disease is it. And then we will prompt different kind of solutions to that farmer, right? Because nowadays for the farming also, a lot of medicines are coming. right? Some of them may be herbal, some of them may be okay fertilizer, but then a particular kind of say insecticide and all is specialized for a particular kind of say rodent or insect or kind of say virus, bacteria or whatever it is. So the farmer can be given the appropriate suggestion on what is the disease and basically what curative measure he can actually take, right? So that's one thing. And now coming to the scope of smart farming technologies, so its basically impact is not just limited to primary production, but you can have big data analytics for the entire farming process. Entire farming process in the terms of, say, you may have that, okay, you may have something like you may have 10 patches of land, and you can analyze, okay, how much yield did particular patches of land give, and you can analyze, okay, this patch of land gave like less yield, and then you can do the analysis, okay, what was the problem and so on. And also it can facilitate real time operational decision making, right? So something like, say, if I have to give you a very simple example, just like say you have an irrigation pattern. Irrigation pattern means basically that on a regular cycles the field is actually given water. Now say based on your whatever IoT platform, you come to know that, okay, in the coming 2 hours it is expected that there may be rain, right? So what you can do is you can actually postpone the irrigation cycle. That means you may say that, okay, I'll wait for 2 hours. If natural rain comes, fine. Otherwise, then I'll see the next prediction and accordingly I'll either give the water or not. Otherwise, you may end up in wasting the water also and the motor running also, right? And many other decisions also can be controlled. Also, it can be used to enhance conventional farming practices. So that's another thing. So we may use both the technology as well as our traditional method. And also it can be used to revolutionize existing business model. So now when the farmer, right, he's just one second. Utkarsh, I have a FDP presentation, so you can please share the link with the students. Yeah? So it can be used to revolutionize existing business models in the terms of, say, if a farmer, right? He is producing something. Nowadays, we are actually developing a kind of method where, right, in the whole supply chain, all the information is in the blockchain, and the farmer will know that whatever yield he is actually producing, what is the different price of it and the different parts of the supply chain, right? So that what it advantage it gives is that he may not be cheated very much, right? It should not happen that the product is being sold in the market for something like 100 rupees, right? Whereas he is basically producing and then the other guy is just fooling him up by purchasing from him in just something like say 5 rupees, 10 rupees, right? So if he is intelligent enough, he may want to explore some other purchasers who can actually purchase at a better price. So in the business modeling and so on, people are actually coming up with, especially given that India is agriculture predominant kind of country. So if you see the complete picture, it is like that, right? So if you see on the left hand side, you have the agricultural land that includes even say something like the animals and so on within that, right? You may have cows and so on, tractors, then you may be measuring temperature, humidity, you have different sprinklers, you may have drones which are monitoring it, right? So all of these we want to make them in a automated fashion. So when you are making automated, there are different purposes for that. One purpose is to track, right? Like the cow. Okay, you may have something like 100 cows. Where are the cows going? Right? Are they going in right patch of land? If someone is actually misplaced, where has it gone? Right? All those kind of things. When it comes to the sprinkler application, which you see the second last in the smart devices, right? You can do something like let me see if I have pointer, right? So if you take something like this sprinkler, you can actually control it in different ways. You can actually control it right, by giving the control signal or in an automated way. So all these devices, the smart devices, they can be controlled. And now there is a edge gateway. So edge gateway is what? Edge means what? It is basically close to the end devices. So what are the end devices and all? They may be tractors and so on, right? All these particular kind of things, they are the end devices. And we have that these kind of edge gateways in the remote vicinity, and these smart devices can actually directly communicate with them. They may be one hop or two hop or so on, but they are like in fact very close to it, right? And they can actually help in making certain kind of decisions. Like if I have to give you a very simple example, if you have a kind of a uh, this water sprinkler, right? So sprinkler, you will just have say something like a solenoid valve. So many of you must be knowing solenoid valve is something like a kind of valve which can be actually controlled by current, right? And you can basically just like you press a button with manually with hand, right? You can have a relay kind of thing. So the relays which are actually used for controlling water, liquids, and so on, they are called solenoid. So you may have a solenoid valve kind of thing. And if that gets opened, right, you have watering or irrigation in that particular kind of field, otherwise not. Right. So now for making this simple kind of decision, there's no need to actually go to the cloud and so on, and there's not too much analytics involved in it. Just like I may have a very simple kind of logic that if the soil moisture goes below say X particular value, then I what I do is I'll basically switch on the actuator. Now, for doing that particular kind of simple operation, you don't need to unnecessarily go to the cloud. Why? Because two, three things. One is you will increase the latency. Another, you will have to pay for the cloud service. And third thing, unnecessarily you will have uh, reliance on internet connectivity. If the internet goes down due to any reason, right, you won't be able to run the system. But if it's being done controlled by a edge server or a edge device which is very close, right? So you save the cost of going to the cloud, and also you can get quick response, right? And you don't need to pay for the extra services. You, even in absence of internet, right, you may be able to carry on the smart farming function. But however, there may be now these edge servers, right? At times there may be certain decisions or certain kind of optimizations which it might not be able to do on its own, right? There, what it can do is it can forward the request to the cloud server. So now cloud server is more powerful. So what it can do is it can do more amount of analytics. Also, it can do something like more amount of storage also, right? It may happen that the edge gateways periodically, right, it's scanning those particular smart devices, and then once in an hour or say once in a day, it's basically sending the data to the cloud service, right? And then basically you have the farmer also who's basically getting advantage from the whole thing. So now when it comes to security within the smart farming application, right? So as I earlier said, once you connect these sensors and so on to the internet, right? So you may have vulnerability to cyber attacks and so on. So one can easily control and exploit on-field sensors and autonomous vehicles. So just imagine that, okay, you are there and you have this whatever farm field and all, and someone is there, he doesn't he is your enemy or whatever, or someone wants to damage say the whole agriculture of a particular state. What he can do is he can control all these edge gateways, and through that he can do a menace, right? He can just put a kind of command that water should go on flowing. He can whatever control the tractors and so on in an wrong kind of way, and the drones and all also he can actually do. And in fact there have been many kind of things, not in agriculture but in other places, where people have actually hacked devices and done. So as we go towards smart farming, we should keep those kind of things in the mind also. So it can actually also cause the destroy entire fields and even cause economic deterioration. Right. So one country can actually use this against another country. Right. If your country has a smart kind of farming and all, right, and the other country, if it hacks into the system and all, right, it can create a lot of devastation. In fact, there have been many kind of case studies, not with, again with farming, but smart grids, right? Like Ukraine is one country where like they have smart grids, right? Everything, electricity and all, they have everything connected to the smart grid. And it so happened that another country, right, they hacked their smart grid system, right? And then they had electric shut off for days together, right? So those kind of things can be done by the another country, right, to harm the kind of. In fact, we have seen these kind of strategies are have been used in past history also. Like all of you must be knowing, right, when the Subhash Chandra Bose, that army was coming from Japan and so on, right? The Britishers in the say eastern kind of states, they burned the entire like farmland so that these guys can't actually get food to eat. So these kind of things are common. So as we move to smart farming, right, those same concepts can be applied by countries to harm the economy of the other country. So specifically agriculture, it's one of the biggest industries and it can have a lot of bad impact on the world. Right? So now coming to, are we safe, right? So cyber attack on food ecosystem, right? So when we talk of farming, right? So a big kind of thing comes because it's the whole food ecosystem and so on, right? So that same yield which is produced later gets transformed into food and gets distributed, say, houses, hotels, and so on, right? So it can be targeted at farms, the transportation of food processing, right, the industrial control systems, etc. And at times it may lead to food related deaths exponentially. So if the food is actually whatever the growth, yield, and so on is, so I think someone has a doubt. So I don't know what is the system, but if someone wants to ask, they can just ask. Not sure. So So that's the kind of thing, right? So say if insecticides and so on are too much in the like put in the crops and so on, it may at times lead to the crop yield itself getting contaminated, right? And then what happens is those people who are eating those food, right, they may get serious disorders. Rather, due to food poisoning, there are a lot of death cases and so on. So other industries they have learned, right, regarding security and all, but agriculture is a low hanging fruit because whenever a technology comes very new, it is very vulnerable, right? So similarly, like we have done one paper had published on consumer IoT and security threats and so on. So there basically we analyze few very popular products in the recent past, right? Even say weighing machine and say the home security system and so on, which are actually developed by very like popular companies, even like Google and so on, and they were actually hacked, right? So they are actually real case studies. So whenever a kind of technology comes new in a particular domain, it is very much like prone to like hacking, exploitation, and so on because it is in a very early phase. So that's why in the agriculture also, because all these things are coming relatively new, that there may be danger due to that. Basically, now once you talk of IoT security, that is one thing. But when you come to IoT applied to farming, right, you have many other additional constraints, right, which make the kind of problem little different from the traditional IoT security problem. Like you may have different kind of farm equipments, right? So and then you may have different kind of operational decisions. So in the field of agriculture, the kind of decisions you make may be different from a traditional kind of say simple kind of IoT system which may be say related to healthcare and so on. Similarly, you have a particular problem of labor sharing. Labor sharing means you have in this particular kind of agricultural model, you have that at times labors are hired, right? So you know that a labor he is coming, right? It may be possible that after 1 month he is not coming, you have to hire someone else and so on. So while actually designing the systems and so on, you need to actually take into account those kind of things also. Not that anyone comes right to your field as a worker, you give him access to all the particular kind of whatever resources and so on. Right, so due to different kind of dynamic things which are added in the farming kind of environment, so we'll see some of them as we go ahead. There's a importance of like a different kind of security solutions. Now, coming to the smart farming architecture, you have different layers. So the first layer is basically the physical layer, which is basically you have real physical sensors, gateways, devices which are spread across in the farms. They may be also drones, autonomous tractors, sensors, hub devices, and so on. Now, it may appear that okay, there's too much exaggeration and all. Oh, we don't have these things in our country and so on. But you may actually expect that in the next 2 3 years, these may come up very quickly, right? Like smartphones also, they all came all of a sudden. Similarly, all these kind of things. Now you are seeing drones also. Recently, I had gone to Goa for in BITS Goa for one kind of seminar and all. So there, like I just went out to purchase toys for some of my relatives' child. And what I see first thing is that okay, that guy was having drone. So he told, "Bhaiya, ye drone hai, ye naya 3,000 rupees ka loge." So these things are becoming so very common, and people are exploring all these kind of applications. So it's not surprising that okay, that it is too very far. It may actually happen in a year or two, and those who will be working in these area may actually get a lot of like edge over others in terms of novelty and so on. Then you have the edge layer, as I explained. It's near to the end devices, the sensors, and so on. It can be used to capture the data. It can be used to for security monitoring, detection, prediction, and so on. Then you have the cloud layer, which has data centers and so on. It can collect lot of data, do lot of processing. Of course, you have a communication layer, which is basically ensuring that all the different entities in your system can actually communicate with each other. Right? So these are the major layers. So this is the big picture which I showed earlier also. So you have this physical layer where you have different sensors. You may have autonomous tractors. You may have and you may have of course have anti-jamming devices, smart agriculture machinery. You have livestock information. Livestock is basically used for something like the cows and animals and so on, whichever you have that. In technical words, people call it as livestock. You may have drones and so on. You have the edge layer, right? Of course, you have some particular communication between them in the form of Wi-Fi, Bluetooth, 5G, and so on. And then, of course, you have the cloud, which has the virtual servers and so on. Right, coming to the security and privacy issues. So one important issue is basically data security and privacy, right? So data security and privacy. So you can see that enormous amount of complex, dynamic, and spatial data is actually generated, right? Whenever you have a smart farming land, right? And the security of the leakage of security data can actually cause potential threats like facilitation or of bypassing security measures, right? So say if the other guy, right, he may get access to your particular kind of data, that what crop is you are doing, how much yield you are actually producing, what insecticide, what fertilizer you are using, and so on, right? It may actually have certain kind of repercussions. It may lead to leakage of crop, soil, purchase information, and so on. It's like, say, if a farmer is there and he is, say, selling his particular yield to a particular supplier at, say, X cost. So he is maybe questions. I'll probably I'll go in a flow. I don't know because then I'll have to exit it. I don't see any way to see the chat messages immediately.
I'm monitoring, Doctor. Uh,
Fine.
there are some questions we can take at the end.
Sure, and I can actually go to those specific slides and right, I can clarify. So going in a flow to the end will give a probably more comprehensive picture. So I'll just explain different kind of scenarios because these scenarios are important to understand. So one, like as I was explaining, the farmer, right? He's having a particular kind of yield and he's selling to the, say, the other party at a particular cost, right? And at a particular time and so on. So, and generally in such kind of things, at times people go for bidding kind of thing, right? So he may bid that, okay, I'm selling to this particular purchaser, a big main purchaser at something like say 10 rupees per kilo, right? So the other party, if he gets those kind of information, he can know the bid price and he can say, okay, I am whatever supplying at something like 9.5 rupees per kg, and he may actually get the benefit and he may be able to whatever sell to that particular supplier and so on. And he can get many other information also, like say if you have a particular kind of disease happening in that particular kind of crop, right? He can get to know, okay, nowadays, okay, at this time this particular disease is happening and this guy is using this particular kind of insecticide or fertilizer, so let me also use, right? Although it may appear, okay, why selflessness and so on, one should be selfless and so on, but at times in market and all these kind of things, at times people have to do like, I'll give you a very simple example. Say a farmer is putting a smart system in his farmland for doing the automated farming and so on, right? He's paying so much high, right? He may be paying something like 2 lakhs per year or per month for using the whole system and all. But if someone is getting access, some other guy, he is getting access to all that particular data free of cost, then why someone will purchase, right? And then there will be other issues that the company may go in losses and so on. People won't be motivated to develop some such solutions and so on. So one important thing is that one needs to take care of the data security and privacy, that data doesn't go outside. Another thing is you have authorization and trust. That means with these many components, right? It's essential to ensure that every request is sent through a trusted authorized entity, right? At times you may have that, okay, you are accessing the data through online mode, right? You have a username, password and all, and for doing any particular kind of action manually, right, you may whatever log in and then you may do particular kind of thing. But say if someone whatever misuses and somehow other hacks into the system, gets the password and so on and on, right? So there has to be kind of authorization mechanism. Just like I'll give you a very simple example which you will be able to relate to. Just imagine you go to your relative's house, right? And you take his system and then you try to log into Gmail, right? What happens? Immediately you get a SMS that is this device trusted or not, right? Why? Because the Google people, they know that people will misuse. People can crack and people can get the username password. That's not actually difficult. So they have actually put up an additional layer kind of thing where, right, you are ensuring that, right, the same person who is actually authorized to use the system, only he can log into the Gmail, right? So here you can have basically irrigation temperature, everything can be actually controlled, and hence using these kind of things. So you should actually take care that the system is secure. Another is authentication and secure communication. So this is one of the most important aspects, right? Is the authentication of connected device. Just imagine what happens if I, as a third party, say a rogue kind of person, I come there and I put my own sensor there and start giving faulty values. So your edge server should be able to detect that a wrong device has actually come, right? So authentication means what? To verify whether the particular entity. So Parikshit sir, can you just once tell me that I have time till what time so I can plan accordingly?
You have time till 11:15, sir.
Fine, fine. Then I'll maybe wind up in maybe 20 minutes, 25 minutes I'll wind up.
Yes,
Fine.
yes.
So authentication means basically you're verifying that the entity which has come into your system is the right the right person or not, right? Just like you have authentication system out of your office also, outside your office, right? You will scan your whatever pass or whatever kind of ID card which you have been given by the company. So that's something like authentication. Before like any device, right? At times it will get authenticated that is it a part of the system or not, so that any other third party entity can't enter. Like you just imagine that there is a edge server and it is basically working on Wi-Fi, right? So the kind of system is made that the edge server is there. You push request into it and then it will give the response. So just imagine a sensor is there, it will actually push some request and then it will actually give the return the value, whatever, or kind of automation and so on. Now, if you come up with a particular kind of device, right, which comes and sends a very similar kind of packet to that particular edge server, right, and it gets a response from that, so it can do that kind of communication for something like 100 times, and then he can understand what is the kind of protocol which is actually going between the device and that particular kind of thing. Right. So I'm not sure. Means someone is saying audio is breaking. I think that might be local problem. If many people are facing, you may let me know. So now, like people have actually used these particular kind of things many places, right? For example, people have actually used these kind of things for spoofing the drones. Like recently, I have been working a lot on the area of drone security. So in drone security, what happens is that when the drones are actually whatever flying, they actually rely on the GPS location data. GPS location data, why? Because say if a drone is going from one location to another, how does it come to know, okay, where I have to go and so on? So you have to do its path planning in terms of the GPS coordinates. That means you may feed that, okay, the initial position of this drone is XYZ, this thing. In the tool, you set it as this is the starting position, and then you have it as whatever the next destination and so on. Now what people have actually done to hack this particular kind of system is many people, they are actually coming up with the kind of messages that whatever message this GPS kind of thing device is actually giving to the drone, they can actually mimic it, and then they can actually pass that particular kind of thing, and the drone will be confused. It will feel that, okay, I am not what is my actual location. It will think it is somewhere else only. Like recently it happened also in Iraq probably, right? So US had actually sent its drones, and then this Iraqian military, what did they do is they tried to hack in a way of, it's called GPS spoofing. So they gave a message to the drone which made it feel that it's back in USA, and just it grounded that same drone, it grounded, right? So these kind of things are actually at times used. So whichever device is actually getting connected to the network or is communicating with your core devices, it's very important that you authenticate them to see that, right, whether this device is genuine and verified and so on. Or so that's another issue we need to take care in terms of security. And then there are different regulations and so on also. So you may have various domains of regulations like contracts, agreements. You may have data security and privacy. You may have intellectual property, some regulatory things. You may have some cyber insurance and so on. And you want that all these particular information, right, stays to you only. It doesn't get right leaked and so on. Now, these are the kind of cyber attacks which can be done, right? So we'll go, we'll discuss them one by one. So you may have data attacks, networking and equipment attacks, supply chain attacks, and there are other kind of attacks also. Now coming to the data attacks, right? We have four different kind of attacks which can actually happen. So now, of course, these kind of attacks which I am telling are little bit in direction of agriculture. From agriculture point of view, I'll be explaining. But if you understand them properly, you can actually understand that these particular kind of attacks, they apply to practically many domains, right? So in fact, most of the IoT kind of applications, these particular kind of data attacks will actually pertain to. So if you understand this subject well, you'll have good grasp on what kind of security attacks can happen and so on. In fact, we have been doing a lot of work on like security in vanets, drones, and all different kind of applications. So the first one is basically insider data leakage. So basically farmers fear leakage of confidential data, right? This is one very important thing, and which I was saying, as you have a commodity market, right? What kind of things are there and all, you don't want that to get leaked. Also, at times you may have this insider data leakages, basically someone within the system, right, doing bypassing and so on, right? Just imagine that you are a big owner of say something like 10 hectares of land, and you have employed something like 3 or 4 like employees who are taking care of the technical kind of part, right? Within that, someone may be doing, say, water quality monitoring and all, one may be managing the supply chain, another may be doing something and all, right? So insider data leakage is something like that. Something like a disgruntled employee means a cheater employee. So he is your employee, but what he is doing is he is leaking the data intentionally, causing you harm or basically selling the data for money. So you want to avoid those kind of things, right? So if you plan things well, right, you can actually avoid these all kind of things. Then there is the cloud data leakage, right? So smart farming data, it's sensitive and it can reveal a lot of confidential agriculture and economic information about the entire country. So when I am saying cloud data leakage, it is something like the other country or say a big adversary is getting control, right, of your system through, right, getting the data from the cloud, right? It's just stealing away the data from whatever is there in the cloud. In fact, we have had different kind of such attacks and so on in the past. Of course, again, not in agriculture domain, but others. Right? At times, you must hear that okay, Yahoo Mail. Some people claim that 1 lakh of the username IDs got stolen and things like that. So that's another thing. So countries itself can actually cause damage to the another country through that. So data might be less secure if stored in data centers in other countries. So just imagine that, okay, you are using cloud services, you have a framework, but imagine that the data center is in China. Right? So in fact, it's in China, so they are having whatever kind of access to all of that, right? Just like Gmail, right? It has access to practically everything of yours. He knows in your Gmail, anytime they can actually crack in, although they at times say that, okay, we won't crack in. There have been court cases in recent past where people have actually whatever sued these big companies also for whatever checking sensitive data and so on. So similarly, if your cloud data server itself is in another country, right? So they can easily have access to all that particular kind of data. So another is false injection data. So false data injection means basically you got hold of the system or the network, and then you are injecting false data into it, right? You may actually inject that okay, the whole land is something like dry, right? And the system may happen that the irrigation, that particular thing, days like they are just going on and going on and so on. Another is basically misinformation attack. So in this attack, the aim is to endanger data integrity. So attacker may release false data about the smart farm, claiming the outbreak of disease in crops or livestock. Right? This misinformation. Right? It may be possible that there is no disease, but unnecessarily it is giving many kind of fake kind of information that okay, here it happened something, or about the livestock, that means cows and all, it may be indicating that they are somewhere where they are not actually. Another kind of attacks are basically networking and equipment attacks, right? So this basically trying to harm the network and the equipments. So one of the attack in that is basically radio frequency jamming attack. Right? So as all of you know, right, the core system and so on in such kind of applications is that they actually work on wireless technologies, right? You may have a controller, right, which is basically connected to the actuator, which may be something like the solenoid or the sensors and so on. via Wi-Fi, Bluetooth, and all these kind of wireless technologies. Now, if you put a jammer in that particular environment, right, what will happen? That signal itself will stop, and right, what will happen? The whole thing will collapse at once. Right? In fact, people in military, they use at times they use jammers, right? If they will have a secret kind of say meetings and all, in that they all put jammers, right? So that no one can use their cell phone. Cell phone they can't use only in such kind of things. They can't do any recording and so on, many things like that. So one particular kind of attack is that if the adversary or the other person comes and puts a radio jammer, that's all, right? For 5 days your entire thing will be jammed, you won't get any signal, all the things will dry and they will finish, right? Another is malware injection attack. That is basically if you have a kind of software or thing which is basically having controlling your system, you can put some virus or something like malware into it, right? Which may actually make it to act in a very improper kind of way. Then you have DOS and botnet attack, right? Denial of service. You can basically this kind of attack is what basically you push so many requests to the edge server and so on that it gets hanged, right? Like if a server is there, right? Server has its limitation, how quickly it can respond and all. If you just bombard it with so much unnecessary, useless requests from unnecessary devices, right? That can also lead to your the whole like network getting collapsed. And so this something which is very commonly used in the generic IoT also for hacking devices or downing the system. And like there were something like a kind of system which people had for surveillance kind of application for IoT, where the camera images, videos, and so on used to actually go to the server and all. Right. So what the adversaries, what they did is they pushed so many requests, unnecessary requests, that the actual user's data that was not getting processed at all. Right? So Mirai botnet and all those kind of things are there. So this one way. And then there is another is side channel attack. It's a side channel attack is basically attacks which have their roots in gaining information from how a system is implemented rather than what weakness exists in the system implementation. So you get to know basically how the system is implemented and all, then you try to actually misuse it in a way of right someone else trying to control it wrong. Now, supply chain is a very, very important part of agriculture. So whenever the food yield is actually produced, in fact, supply chain at times it comes, the agriculture supply chain, it comes in agriculture category only. So once you actually have good amount of yield produced, right, it goes through different phases, different kind of parties, intermediaries in the between. Like the farmer will produce, then it will go to the next person, then it will go to the next person, and so on, right? So here you may have different kind of attacks. One is basically the third party attack. That means two people, right? The farmer and the other guy, they are transacting, and then a third person comes in between, and then he whatever. Say this guy put a bid of something like I want to sell at 10 rupees per kg, right? And in between this guy comes, what he does is that 10 he makes as something like 25, and the supplier or whatever the purchaser, he sees, oh, he is actually selling at 25, oh, I won't take from. So although he had intended something else, right, you could actually do these kind of things. So in specifically in stock markets and all these kind of scenarios where you deal with finance and all, these particular kind of hacks are very much used. So here also they can be actually used. Then you have another supply chain software update. So this kind of attack is basically once the software of whatever your smart farming system is getting updated, at that time, right, a particular kind of bot or a particular kind of virus can be actually put, right, so that the system gets whatever kind of corrupted and all, right? And then there is data fabrication attack. Data fabrication attack is basically you fabricate the data and put some false information, which is basically put, and based on that, the devices may take wrong decision. You may actually fabricate data that okay, that whole land is something like dry, whereas it might not be. In that kind of scenarios, right? It may lead to, or you can do many other kind of things like that also. Then you have supply chain interdiction attack, right? Supply chain interdiction attack means you have particular kind of norms and so on, right? When you are trading and all, one may actually hack into that, change that, modify that, and do things like that. So that's that particular kind. There's other relevant attacks also like compliance and regulation violation, right? So here basically specifically you whenever you have right particular kind of thing, you have certain regulation, you have certain kind of compliances. So adversary attacking a smart farm can specifically inject false data that will impact various compliance certification processes. The certification process, if invalidated, can impact nations food supply, affect crop price and all. So this at the higher level that say there may be compliance that okay, this much land, this thing should be done and all. You may actually change that. So cyber terrorism is again many like kind of hackers such come together and then they try to whatever affect the whole country's economy and all. Then you have computing attack. So any machine once infected can be employed as a part of global botnets, which can actually use to launch large-scale DOS attacks and so on to hinder the functionality of the cloud. Right. So it may be possible that in the smart farming kind of environment, you have 10 farms, and one farm you get control over it, and then you may actually even collapse the cloud or something like that by pushing on lot of false data and so on kind of things, right? So that's another kind of possibility. So in terms of solution, right, there are certain solutions which are possible. So one is basically you have cyber attacks, threats, and proposed solutions, right? Different kind of solutions, whichever are applicable to IoT. Like say, if I give you some example, you may have physically unclonable function, or basically a particular kind of chips which are installed on those particular edge devices and those particular smart farming devices, which ensure that right the proper authentication is done and things like that. Right. Another direction where people are exploring security for farming is using blockchain kind of application. So blockchain kind of application, so it makes the data untamperable. No one can change it. Like I will give an example of from the one party. If say he's bid something, right, intermediary, some person can change, but the blockchain will basically ensure that those data cannot be tampered. It is basically stay saved properly, and you can have smart contracts which are automatically making like things do and so on. So that's another stream of kind of application. So however, I'll tell you frankly, in the smart farming kind of this security scenario, not too much work has been done, and it is a very new kind of area. So people like they are exploring and so on, something like that. It's a very new field actually. Another is basically you may have AI and machine learning assisted work. That means you're using AI and machine learning to detect that by seeing the pattern of the input signals and so on, you may try to infer that is this particular kind of attack coming from like a kind of a rogue device or a normal device, or you may see that okay, there's a typically a very like a sudden increase in the number of signals coming from this particular kind of end device. So using AI techniques, you can very easily detect any kind of anomalies and so on, and you can use them to actually reduce this particular kind of attack. And of course, there are many another kind of things also, which like is are sometimes beyond scope of we can't explain in such short time, right? So what challenges can be improved on, right? So these are the open research challenges for security and privacy in smart farming. So one is basically you have access control, the trust and privacy perspective. Right, from that basically perspective, you can develop farm specific access control mechanism and solutions. You can also create specific data sharing and ownership policies. Right, you can develop models that handle temporary labor and livestock specific use cases. Like I was telling that, okay, you may have kind of a scenario where you have many labors which are coming in a kind of a rotation kind of fashion. So there you may choose to actually give access to some particular kind of data only to a particular kind of thing of a person, right? Rather than giving the access to the whole system. From data perspective, you need to prevent insider data leakage. So there is like another lot of scope of research in that, that how can you ensure that whatever data is there, right, it is in a format which can't be copy pasted sort of. You just imagine that you build a kind of a system where you can just visualize the data and you can say give some commands and all, but you can't just copy paste the entire thing, right? It's not in a copyable format. Right? Only the administrator, who is say the owner of the farm, he has the rights to whatever copy paste. Others can just view it. And also you can have something like, okay, any kind of say thing which is very critical needs to be done, it requires authentication of the owner of the farm. You can do all those kind of things. So you can create malware and zero day attack detection and identification tools for smart farms. Also, you can develop AI assisted intrusion detection schemes and models. So again, these things may look okay now. Right now, we don't have any works in these areas. But of course, over a period of time, in 1 2 years, you will see a lot of works coming in that. Right? Like if I have to reflect in my own case, when 2 years back, I had started working on almost 2.5 years back. I started working on drones. Right? The area was not so very ripe, right? So that time we could somehow or other start and we could actually publish several, like around 10 to 12 journals we have on drones, which actually cater to different kind of problems like the energy charging management, the security, and then say agriculture and all these kind of different application, like say in imaging in smart cities, and say the path planning of the UAVs. So all these kind of things. But now if you see, people are like, so many people are working on UAVs throughout the world. It's like in IEEE Explore itself, there has been a very sharp increase in that whole thing. So similarly in the agriculture also, over period of next 2 years, we can actually expect many of these actually things coming up. From the network perspective, you can deploy cross-layer network security solutions. Of course, I can't actually go into each one of them because each one of them again becomes a very broad category. Of course, later on, if anyone wants to collaborate with me on security, VANETs, UAVs, or like 5G and so on, right? They're most welcome. We have been doing work in these areas since some time. You can also develop software-defined networking, right, for smartphones, so as to secure it. In terms of compliance and supply chain perspective, you can have secure supply chain using industry specific cybersecurity standards. You can protect agribusiness and cybersecurity using legislations. So there's another thing. Currently, at least in India, there are not too many rules and so on for cybercrime in agriculture. So if some say ex-farmer is there and some other guy, he whatever tries to do that, okay, he tries to say take away the data or steal the data or try to control its devices and all. There are no proper norms or legislations and all in like our government and all, which basically says that okay, this much punishment will be there if such thing is done. Of course, so those things also later on government they can work out. Also, you can create robust farming specific cyber insurance policies. So just like you see nowadays, like people will be just saying, earlier it didn't used to be there. Nowadays, you for your bank account also you have to take that cyber security thing, insurance. Why ICICI will tell that okay, you take this insurance, and if some fraud happens, all of a sudden money is lost, then we'll track it, we'll give it back. Similarly, in the supply chain of the agriculture also, we can have something. So of course, I would apologize if the presentation didn't go too very deep, because this area itself is very much in the initial stage. So I means to get the data, to get collect the content and all itself for it was quite actually challenging, because if I have to take for an area like UAV or say smart grid, it has been being done for last 3 4 years, 5 6. It has already quite mature stage, and people have even made such systems and all. But when it comes to agriculture, it is quite in the beginning phase. So now I would open up to questions, right? You may feel free to ask questions, not just related to this, but if you have any generic query related to the whole presentation or some other thing, right, related to security, you can feel free to ask.
Professor, good morning.
Yes, sir.
I am
Good
Dr.
morning.
Mohan from Bangalore. Excellent presentation, Professor. We really got a great information from your lecture, and have a small question for you. In the
Yes.
entire session, I heard about the security and the technology as well as the implementation of the devices, but the cost is concerned. I not got any information. Can you put some view on the cost? Example per acre, if we go for implementing this IoT facility based, and how it will be, and what is the yield versus cost analysis, if anything is made or any paper is made, can please highlight. It's extraordinary lecture we enjoyed. Please answer this, Professor.
Mhm. So basically, if you go about the cost, it will very much depend on the kind of solution you are applying, right? As you see over here, when you take the smart farmland, you have so many things to actually implement, right? If we take out drones, right? Drones may be something like optional, which will be used in very rare circumstances. But of course, one thing which will be, of course, there is basically you will have certain kind of sensing of the soil in terms of say humidity, moisture, and so on. You may have some other kind of sensors which may actually even measure the concentration of the insecticide, pesticides, and so on, right? And then you may have certain kind of microcontrollers and all which are actually doing the communication between them, right? If you see particular kind of implementations, right, to take give you a very simple kind of example, because I have not actually come across these figures, but I can actually introspect in terms of a small patch of land. Just you take a something like
1 acre.
20 meter by 20 meter kind of land, right?
Oh,
Within that, you may have something like you may have four soil moisture sensors or two, depending on what kind of setup you want to have. There, once you have that particular kind of soil moisture sensor, if you take a soil moisture sensor, just 1 second, let me put the battery. So you have a soil moisture sensor which comes from around probably 600, something like that. And then you require a microcontroller, because a sensor in itself doesn't have its intelligence, right? So you will require a particular kind of microcontroller which is getting the input from those sensor. So
2000.
that particular thing may actually, like if you take Node MCU, it will cost something 300 or 350 rupees. If you have something like say Arduino, it may cost around 500 rupees. But of course, I'll tell for all of you, Node MCU or ESP8266 is a very better platform, what I feel, for these all kind of applications as compared to Arduino, because Node MCU or ESP8266, the coding platform and all is exactly same as the Arduino, but it has many better functionalities in terms of it has inbuilt Wi-Fi module. It is first of all cheaper, right? It costs around almost just 300 rupees. It has a built-in Wi-Fi module so that it can actually connect to the edge server. So you may have an edge server which is say something like catering to a something like 40 by 40 kind of 40 meter by 40 meter kind of patch of land, and you may have that particular edge server in the between and all, right? So if you have, yes, Node MCU, right? Node MCU basically at times people call it ESP8266 and so on. So you can have wirelessly data, that sensor data, coming to the node MCU, and node MCU further relaying it to the that particular say edge server over Wi-Fi, right? So again, if you have that particular edge server, many a times for if very simple kind of applications, you may use Raspberry Pi as the edge server, which is the simplest kind of scenario when it comes to say most of us are in academia. So if we have a build a particular kind of smart farming prototype, we will put Raspberry Pi, it will cost around 5,000 rupees. So you may have the entire like kind of thing within 10,000 something like that, or 7,000, 8,000 like that. And then of course you give the internet connection to the Raspberry Pi. So you will have to put a GeoFi or something like that to give it internet. So that's a rough kind of estimate. So in addition to these sensors, if you are having another sophisticated sensors or automated tractors and all, which may not be immediately applicable, the cost may actually increase and it will actually depend on the particular kind of thing.
Yeah, Professor, very nice. As you seen in Europe and all, you give an example. In that
Yes,
reference, can you highlight little bit? For example, 20 meter by 20 meter, you account to you, it comes to 5,000. In that sense, if we see acre wise, somewhere you told yield and the finance, approximately, you told me, it's already been implemented in Western countries and Europe countries, right? So,
yes, yes.
any data regarding if you tell, I will be thankful and I end my question. Others will
I
participate.
am really sorry because I don't have much because agriculture is part of my
Yeah,
primary area of
very nice,
business.
very interesting. That's why. Yeah, very good, very good.
I
Yeah,
just prepared this because Parikshit ji told that okay, you have to do security in agriculture. So I anyway
yeah.
got
Oh, nice, extraordinary lecture. I really excited lecture. Very nice. Thank you very much, Professor. Thank you very much.
thank you.
Hello.
Dr. Vinay,
Yes,
uh,
sir.
as you can see, the very that audience is appreciative, and what I'll do, I
Yes, sir.
will read out some chat for you. That there
Sure,
some they have mentioned some questions,
sure,
like
sir.
one Mr. Pritesh Saxena. He wants to know how data integration will be done for the data received from various sensors deployed.
Okay, so the data integration, how basically it is done is that you have this particular edge layer. So you have these all physical devices, so which I was showing. So the data integration is typically done in a way that you have these smart devices. They are actually producing that particular data corresponding to what particular kind of thing they are measuring, and that all data actually goes to the edge server first, or the edge device which is in the vicinity, and then later it can do different kind of things over it. One, it can make a local decision of say a particular kind of automation in terms of watering and all, or it can actually send that particular data to the cloud server. Now the cloud server, it can actually do something like analytics for, right, what is the kind of say water required, what are the humidity patterns and so on. So all those things can actually like work out. I didn't actually exactly understand what was meant by integration, means in terms of what perspective is being said, but this the
Maybe
like
from
very broad.
various sensors it will come. I think you have you are showing through this pictorial diagram to
Yes,
the,
yes.
so you can
So,
integrate.
so if I'll explain you here, you may have, okay, like say the sprinkler is there. Below that, you have a particular kind of node MCU, that device. Then that is basically connected to the soil humidity sensor. Then that sensor is basically giving the data to the node MCU. Now, node MCU, it can be actually powered easily. You can put two Duracell batteries, things like that, and you can actually power the node MCU. You can make a package waterproof, and you can actually give power to that particular kind of system. And then node MCU can wirelessly, it can actually give the information to the edge gateway, which may be in the form of Raspberry Pi. So you can have this particular kind of communication in a very very easy way. You will find lot of like online resources and all. So and further, it can actually, the edge gateway can give commands that okay, if soil humidity is becoming less, you may have a solenoid over here which is also connected to the node MCU, right? And the node MCU can further make the solenoid open so that the water can actually start flowing. So you can have the data flow in this particular kind of way, in this particular kind of scenario. And if more number of sensors are there, similarly, they will be connected to the edge gate.
Yes. The next question is from Dr. C.H. Vitlani, that he wants to know that he was just scrolling to the Facebook page and clicked on certain car advertisement, and
Mhm.
immediately some call came to him that he has visited his page, Facebook page, and
Mhm.
he's asked about his interest in buying the car.
Mhm.
And then the person was having the contact number, and it seems he had all the information. So he
Mhm.
wanted that how to secure through Facebook data.
So
I
actually, this has become a very, very big problem because as you must be knowing that there are whole lot of companies whose business itself is to sell data. So data is very, very precious thing. Actually, we don't realize many times what happens is online when we are purchasing anything or for any particular kind of thing, we're just putting our name and phone number, email ID and all. Right? What people do in the back end is, right, there are whole lot of companies who specialize in collecting all that particular kind of information and then they sell it to vendors, right? Like say insurance companies, and then there are a whole lot of companies. So that's how basically your data is exposed, and we can hardly actually help actually that. So only way is when we are actually making accounts and so on, we should whatever try to log in and all, give information only to the reliable parties. Otherwise, a lot of information gets, so we may. And people are actually doing this thing that has become very common, that if someone is visiting your website, right, there are companies which are like, in fact, I also own a startup. So I own a startup on healthcare, right? So I was actually approached by such one company, and they told that your website is there, and they told that okay, whoever comes and visits your website, right, you please take our this one monthly plan, and you can try it out, test it out. Whoever will visit your website, right, we will have a automatic chat box for them, chatbot for them, and in addition we'll also provide their details like whatever email ID they are currently logged in using. So we'll give that information to you. But of course, right now our startup is in quite initial phase, so we didn't purchase it. But this data selling business has become very common. That's why again the security and so on, right? It comes into picture very much. Now this was your just that simple kind of application. It is not very critical. Okay, person called. Okay, you purchase, you whatever went to the website of car and all. But you just imagine that if they can do something more, right, which may be more harmful, so it may be very, very dangerous. So implementing security nicely in whatever solution we are developing is very, very important actually.
uh, the next question is from Madhur Dev Upadhyay, that similar to the previous one, how to interface network layer and edge layer. We use Wi-Fi or Zigbee like wireless modules easily available in the market. How to ensure the robustness of our IoT system against the RF jamming and interferences?
Regarding RF jamming and interference, you can't actually do much. That's kind of a physical kind of thing which can be done by intruder. But I'll say that currently at least we don't have such kind of, although it's like possible, but at least in the field of agriculture, you don't have too much kind of this thing that you have other guy coming and putting the jammer and all. At least currently it's not like that. In fact, coming to the wireless technologies which you mentioned, of course, Bluetooth won't be very good. It doesn't have good range. Wi-Fi is one good option. Like I gave a case study where you have the irrigation thing, this particular sprinkler, and then you have Node MCU, and it is wirelessly sending to Raspberry Pi and so on. So it has typical range of something like 25 meter. However, if you are actually using Zigbee modules, that is also one very good option. So advantages, you have low power consumption and you have a larger range. So Zigbee can at times go up to even 100 meters, and although they technically say although little less, but anyways, it has much better range than the Wi-Fi, and it has a lower power consumption also. So one can actually go with that kind of, and that is very much like popular kind of that an alternative actually using Zigbee kind of transmitter receiver. In that you just have that, okay, near to the sprinkler you have one Zigbee something like transmitter, and in the edge gateway you have a Zigbee receiver, right? So the transmitter receiver, they can communicate. Of course, you will require some microcontroller and all also, because I'm not very sure if Zigbee can actually control sensors and all also.
The next question is from Mr. Sarin CR to that how reliable is Node MCU under hard environment? What may be the life cycle of Node MCU?
So of course, the like waterproofness is one constraint, but people have developed even for Raspberry Pi and so on. So all these are things you have that constraint of that water. They come in exposure to water, right? The connections may come together, and there may be short circuits and all sorts of issues. So one, when while developing the solution, one has to take into account that particular kind of thing. So there's no like exception to that sort of thing.
One second. The next question is that is wireless sensor network authentication protocols applicable to IoT-based smart farming?
To be frank, actually, IoT is also an extension of wireless sensor network. So earlier, 10 years back, when I was a student in my BTech, we just used to tell wireless sensor network. Now, somehow or other, because this IoT has come, that means you have connected it to the internet. Right now, wireless sensor network sort of like it has become like the outdated kind of thing. People see in that way and so on. But of course, the protocols which were actually used in the wireless sensor network kind of environment, they can be very much modified and adapted to this particular kind of IoT scenario. In fact, if you see even many big researchers also, at times what they do is they just take say routing protocols or so on, which were actually applied, or energy management techniques which were actually applied in wireless sensor networks, and then they are just doing the same kind of similar kind of thing in the IoT environment, and at times they are able to publish in very good venues also. So I would say that with little bit adaptation and modification, that can apply to like this kind of thing, because like that. Of course, there are few other things also which will come into play, which were not in wireless sensor networks, like okay, the like being connected to the internet, right? More number of attacks are possible and all. So you need to check into that also, that what kind of security you are targeting. If you're just targeting the security of smart devices, right, you may be able to do limited using those old kind of protocols, but then you must actually look into another kind of things. In ask questions, sir.
There are some question on Mr. Amit Kadam has asked that food safety and transportation. This question we can keep for tomorrow, Kadam sir. We'll have our expert from agriculture domain, Dr. O.P. Yadav sir and Dr. A.K. Gupta sir. So they can deal with these questions. So because they are from agriculture background, so they can answer that very nicely. Then there is what are the some Mr. Krishna Samdani wants to know what are the various methods for security through which one can perform authentication, like you were talking about device authentication. Can you give any example of it?
Authentication, when you talk of authentication, it works at all different kind of ways. Like we have been doing actively lot of work on authentication. So authentication can happen in terms of, right here, if you see the edge device, edge gateway, and the end devices, you may have authentication between them, right? So that to other false smart device which is not actually intended to come, which is like coming into role. So you may have basically kind of authentication mechanism, you may have authentication mechanism that ensured between edge gateway and cloud server. It may very much happen that you may have another edge server, edge gateway, which an anonymous person is actually having, and then he can actually connect server in a very normal kind of way, like a normal edge gateway actually connects, and then it can actually start giving false kind of data and so on. So whenever we actually talk of security, we have to consider all the different layers. That means between the smart devices and edge gateway, and also between the edge gateway and the cloud services. So all the layers we need to actually secure.
Now I'll take at the end two more questions only. That as 7 to 8 hours power supply is available for the farming lands in rural villages, will this model of IoT can be possible to take smart decisions by the devices used? And is there any power optimization technique available for IoT? These are the two last questions, sir.
So that is actually, this can be actually done in a like simple way. You can have basically these edge devices and say even the microcontroller, which is basically powered by solar energy. Right? This is also actually a very booming kind of thing where you are actually people are talking of green IoT, green edge computing, and so on. Where basically you try to say that these edge gateways itself can actually harvest energy. So that can be one kind of solution that that is devices all solar and so on. Also, they have another option, of course, when they and so that's one way like that can be. In fact, see that PlayStations also, right? When the light goes in the big area, still the like seller activities and all that they go on. And uh, or say the sensing microcontrollers, right? You don't require so much energy. So that can be done by having rechargeable batteries, or you can have solar panel kind of solutions. So in fact, these are like very, very upcoming kind of fields, like very nice questions. And in fact, there is a lot of, if you do research on this, very good actually papers can be presented and so on. Optimization, I'll tell that basically whatever power optimization techniques apply other places, so they can apply here also. So I'm very thankful that like you have attended it so patiently and you liked the presentation so very much. So in fact, for future, anytime you want to be in touch, you can just you can find my publications. So if you are working in related areas and all, we can do work together and all, and can always have any inquiry regarding security or IoT, blockchain and all. So we can be in touch. So, and also I would like to thank Parikshit sir for organizing such an informative FDP for all the attendees. Thank you.
Professor, give your
Thank
mail
you.
ID, Professor.
Email ID is vinay.chamola @ bitspilani dot pilani
Yeah,
dot
1 minute. We'll write down 1 minute.
so if you
Slowly, slowly. 1 minute.
uh, yes, I think a better search if chamola. So first
Yeah, in
thing
chat,
which will
somebody
come
can
in
type it, please.
website,
In the chat, somebody type.
yeah,
Dr. Mohan, if you will type in the
Parikshit
Google
sir.
Vinay Chamola Bits Pilani, then sir will come, his search will come the first Dr. Chamola only.
Okay, very
If you,
good. Thank you, sir. Thank you.
Vinay Chamola Bits Pilani, if you type, then his profile comes on the top. That is how
If you do
Thank
I
you.
found it for giving his introduction. I tested this thing today only. Uh, I would like to thank you, Dr. Vinay, that he is so humble and so patiently he has delivered lecture. When I took my request to him, then also he was very gracious and kind enough to accept the invitation, and in a way
We are
he
really
to take more
so
he Dr. Chamola was willing to take more sessions for this. Again, I'll keep that in mind, and maybe I'll collaborate more with Dr. Vinay in the coming future, so that my all audience can greatly benefit out of it. So thank you everyone. So we'll break for today. That we'll meet at 2:30 p.m. for the next session. Thank you again.
Thank you, sir. Thank you.
One thing I would like to inform all the audience and I constantly giving to the I am not. I am not taking any separate attendance. As I said, whatever the WebEx will record the attendance to the meeting participants, the same thing I will consider that as the attendance. So I have no interference in that. It is auto generated by the software. So I hope you will appreciate that. I did not wanted anyone to miss the attendance. If you float the attendance in between the session and you start filling the attendance form and you get distracted, I did not wanted that. So I just whatever the WebEx is giving me the list of participants, I am taking that. Only I will request all the participants use a common email ID. Otherwise, what I have to do, I have to research every time. I have to mail that to individual participants, and it becomes a little cumbersome. So I'll request a participant cooperation so that my effort will. Anyway, I'll find out who was the participant. That was no problem, but it takes little time till night 11 p.m. Okay, thank you. Again, thank you, Dr. Vinay. Now I'll stop for today. Will meet at 2:30 p.m. Right? Bye.